Hello! In today's episode of Bug Bounty Reports Explained, you will learn how Frans Rosen was able to access millions of files by bypassing AWS S3 signed URLs. The vulnerability was rewarded $25,000. The write-up, originally published at Detectify blog, is linked in the description. Detectify is also a sponsor of today's video. It's a dust scanner powered by leading ethical hackers in the world. Their payload-based testing finds undocumented vulnerabilities from OWASP Top 10, vulnerabilities behind authentication, misconfigurations in cores, S3 buckets, encryption, and much more. Detectify puts hacker knowledge into hands of security engineers to fix their applications. Start a free 2-week trial on detectify.com/bbre to see what it finds on your website. AWS S3 is Amazon's service used for storing files in the cloud. When the application needs to show the user a file that's stored there, the developer has at least two options. Let's say it's an image. One option is to basically stream the file from the S3 through the server. But you can probably tell that this is not the most optimal solution. It adds latency and uses resources of the server. It would be much better to let the user download the file from S3 bucket directly. However, how do you then make sure that users only download their own files? If you make the bucket public, then there is no access control at all. This issue can be solved using S3 signed URLs. It works this way. A user wants to download a file that's stored on S3 bucket. The server generates a specific link for that user that's only valid for a limited time and for the one specified file. With that link, the user can access the file from S3 bucket directly. But what is that special in this link? Among other parameters, this link contains a signature. The signature is only valid for this one file. If you would try to access different one with the same signature, it will not work. The same goes for accessing a file after the expiration period. The signature is generated on the backend. To create it, the server uses a secret key which, as the name strongly suggests, is secret and not present in the link. It is 40 characters long and the signature uses SHA-256. The brute force of this would take ages, so for sure we will not be able to generate our own valid signature. We need to find another way to hack this mechanism. With such things, it's usually better to not look for a vulnerability in AWS mechanism, but in its implementations by developers. We know that we won't break SHA-256, but what if we would just ask the server to create a link to a different file? For example, you can use path traversal to get a signed URL to a file from completely different directory that the developers wanted to allow. But the problem is, even if we can read arbitrary file, we don't know what files are stored there. We would have to blindly brute force file names, which would significantly reduce the impact. However, if you could get a signature for a directory, not a file, and the server would have list objects permission, you could get directory listing. And I know from experience that some developers absolutely love storing everything just in one bucket. Receipts and reports mixed with CSS and JavaScript files separated only by different directory. But coming back to our undisclosed application, there you requested a file using S3 key with the file name and random key parameters. Then the application opened the URL with this random key in the path, which then redirected to the signed URL. Why did they take this additional step? I don't know, but what I know for sure is that S3 key was not validated at all. You could just put the / there, follow the redirect, and there was directory listing of the whole bucket. And inside, millions of files. Basically all of their data was stored in this bucket. The hunter quickly reported it and got 15,000 bounty plus $10,000 of bonus. To fix this, you mustn't store internal files along with user files in the same bucket with the same permissions. You must somehow separate it. I think the main takeaway from this report is that if something is signed or encrypted, doesn't automatically mean that it's secure. Anyway, if you've learned something new today, leave a like or leave a subscription. Also, sign up for BBRE newsletter to get more tips and tricks. For now, thank you for watching and goodbye.